Imagine standing in a park, picking up a ball, and giving it a good throw. You watch as it arcs through the air, soaring for a moment before gravity takes over and pulls it gently back down to the ground. This is how things work here on Earth. Gravity is always in charge, making sure nothing floats away for long. But once you leave Earth and head out into the vastness of space, the rules start to change. Out there, in the weightless expanse between planets and stars, objects can move in ways that seem almost magical to us. Take comets, for example. These fascinating space travelers are like giant dirty snowballs made of ice, dust, and rock. They zoom through the solar system at incredible speeds, following paths that are wild and unpredictable. Unlike the steady, predictable orbits of planets, comets can suddenly swerve, speed up, or slow down. This makes them a real challenge for astronomers, who have to keep a close watch to track their every move. The orbits of comets are nothing like the neat circles we see with planets. Instead, they're stretched out and chaotic, more like wild roller coaster rides that twist and turn through the solar system. Some comets take hundreds, even thousands of years to complete just one trip around the sun. Along their journey, comets can be pushed and pulled by the gravity of nearby planets, which can send them off in new directions or speed them up unexpectedly. But that's not all. Comets are also known for their dramatic jets of gas and dust. As they get closer to the sun, the heat causes their icy surfaces to vaporize, shooting out streams of gas that act like tiny rocket engines, nudging the comet onto a new path. Because of all these unpredictable twists and turns, scientists are always watching comets closely. Every time a comet does something unexpected, it's a chance to learn more about the mysteries of our solar system. Recently, astronomers were amazed when one particular comet made a dramatic turn in its journey. Its new destination? Mars. This sudden change has sparked excitement and curiosity among scientists and space fans alike. The universe is a place full of action and surprises, and comets are some of its most unpredictable and fascinating dancers, always keeping us on our toes. So, what makes this latest comet so special? Let's dive in and discover the secrets behind its incredible journey through space. Meet 3 I/Atlas, our rare visitor from beyond the solar system. The I stands for Interstellar. This comet isn't from around here. It's only the third of its kind we've ever seen. Discovered by the Atlas survey, 3 I/Atlas was quickly recognized as a one-way traveler, not bound to our sun. It's like a time capsule from another star, carrying clues about how other solar systems are built. Scientists rushed to study its size, speed, and composition before it vanished forever. But then, something incredible happened. 3 I/Atlas changed course. Instead of heading back to deep space, it took a sharp turn. Now it's on a path straight for Mars. This unexpected detour has made it the most talked-about comet in astronomy. What secrets does it hold from another world, and why did it suddenly change its mind? Tracking a comet is tricky, like guessing where a fly will land. For months, astronomers watched 3 I/Atlas, expecting it to swing by the sun and leave forever. But suddenly the comet started drifting off its predicted path. At first it was a tiny difference, but soon it was clear. Something was pushing 3 I/Atlas onto a new course. Scientists checked for gravitational tugs from planets. Nothing matched. The math was right, but the comet was moving on its own. Updated models showed a shocking result. 3 I/Atlas was now set for a close encounter with Mars. The interstellar tourist had decided to stick around, and its new path was a cosmic surprise. What could have caused such a dramatic swerve? The answer would reveal just how unpredictable comets can be, and it would keep astronomers glued to their telescopes. So, what exactly pushed 3 I/Atlas off course, sending it on a new and unexpected journey through our solar system? The answer is both fascinating and a little bit mysterious. The culprit wasn't an asteroid collision or a gravitational tug from a planet. Instead, it was something much closer to home for the comet, its own internal engine hidden beneath its icy surface. As comets like Atlas approach the sun, their frozen surfaces begin to warm up. This heat causes the ices, water, carbon dioxide, and other volatile materials, to sublimate, turning directly from solid to gas. The result? Powerful jets of gas and dust erupt from the surface, a process astronomers call outgassing. These jets don't just create beautiful tails, they act like tiny rocket thrusters, pushing and nudging the comet in unpredictable directions. The force from these jets can be surprisingly strong, especially if the outgassing is uneven. If a particularly powerful jet erupts from one side, it can dramatically alter the comet's path, sending it veering off its original trajectory. It's like a cosmic game of billiards, but the cue is inside the ball. That's exactly what happened to 3I/Atlas. A massive outgassing event, essentially a sudden explosive release of gas, gave the comet a powerful shove, changing its course in an instant. Scientists believe that a crack opened up on the comet's surface, exposing a hidden pocket of volatile ice. When sunlight hit this fresh ice, it vaporized rapidly, creating a huge plume that acted like a jet engine, pushing Atlas onto a new path. This self-propelled maneuver is what makes comets so unpredictable. Unlike planets, which follow stable, predictable orbits, comets can suddenly change direction, making them the wild cards of our solar system. These sudden changes can send comets careening close to planets or even out of the solar system entirely. It's a reminder that in space even the smallest forces can have dramatic effects. The journey of 3I/Atlas is a perfect example. No matter how much we study the cosmos, there's always room for surprises. In space, you truly have to expect the unexpected. Now astronomers around the world are closely monitoring Atlas, studying its light and tracking its movements for clues about the outburst and the comet's composition. Every twist and turn in its path adds to our understanding of these ancient cosmic wanderers, helping us unlock the secrets of the early solar system. And this time, the lesson Atlas has taught us is truly unforgettable, a vivid reminder of just how dynamic and surprising our universe can be. Now 3I/Atlas is hurtling toward Mars, and scientists are buzzing with excitement, and a bit of worry. Mars orbiters like NASA's Reconnaissance Orbiter could get a front-row seat, capturing images and data as the comet flies by. This is a rare chance to study an interstellar comet up close, revealing secrets about other star systems. But there's risk. The comet's debris could threaten our spacecraft. Even a tiny pebble at these speeds can cause serious damage. Mission controllers are planning to move orbiters to the far side of Mars during the flyby, using the planet as a shield. It's a delicate balance. Get close for science, but stay safe from danger. The encounter could teach us about both comets and Mars's atmosphere. It's a cosmic experiment no one planned, but everyone is eager to watch. Will Mars get a show or a scare? Let's put 3I/Atlas in perspective. Its nucleus is about 5 kilometers wide, a mountain of ice and rock racing through space. The surrounding coma stretches tens of thousands of kilometers, and it's moving at 50 kilometers per second, over 100,000 miles per hour. That's 50 times faster than a rifle bullet. At that speed, even a pebble is a hypervelocity cannonball. The energy it carries is immense, enough to cause catastrophic damage if it hit a planet. Thankfully, a direct impact on Mars is unlikely. But the scale and speed of 3I/Atlas remind us why scientists are watching so closely. In space, size and speed mean power, and comets have plenty of both. This is why every close encounter is a big deal. Earth has had its own close calls with cosmic visitors. In 1994, fragments of comet Shoemaker-Levy 9 slammed into Jupiter, leaving scars bigger than Earth. The 1908 Tunguska event in Siberia flattened thousands of square kilometers, likely caused by a small comet or asteroid exploding in the atmosphere. More recently, the 2013 Chelyabinsk meteor exploded over Russia, injuring over 1,500 people. These events show that even small space rocks can cause big problems. Most arrive with little warning, reminding us to stay vigilant. Each close call teaches us about the risks and helps improve our tracking systems. While 3I/Atlas is heading for Mars, every encounter is a lesson for Earth. The universe is a shooting gallery, and we're learning to spot the incoming shots. That's why planetary defense matters, and why we keep watching the skies. What if a comet like 3I/Atlas was headed for Earth? Don't panic, scientists are always on the lookout. Programs like Atlas scan the skies for threats, giving us years of warning if something big is coming. If a dangerous comet was found, we have plans. Crash a spacecraft into it to nudge it off course or use a gravity tractor to gently pull it away. NASA's DART mission proved we can change an asteroid's path. The odds of a civilization-ending impact are tiny, but smaller objects are harder to find and still pose risks. That's why tracking every near-Earth object is so important. Early detection is our best defense. The more we know, the safer we are. Planetary defense is our insurance policy, and it all starts with watching the sky. The journey of 3I/Atlas is more than just a story about a distant traveler in space. It's a powerful lesson in cosmic responsibility, reminding us that our actions here on Earth ripple out into the universe. By tracking comets and asteroids, we're not only mapping our solar neighborhood, but also learning to recognize potential dangers long before they reach our planet. This vigilance is crucial, as it gives us the chance to prepare and protect ourselves from threats that may seem distant, but could have real consequences. This is not a task for one nation or one group alone. It's a global effort, uniting scientists, engineers, and space agencies from every corner of the world. Together, we share knowledge, technology, and discoveries, building a network of planetary guardianship. Over the years, we've developed advanced tools to spot interstellar visitors, calculated their complex paths through space, and even sent robotic explorers to study them up close. Each mission brings us new insights and helps us refine our strategies for planetary defense. Every discovery, no matter how small, expands our understanding of the cosmos and strengthens our ability to keep Earth safe. These moments of triumph are shared by all humanity, as we celebrate the progress of science and the safety of our world. The universe doesn't recognize borders or divisions, it sees only one planet, one home. That's why planetary defense is a shared duty, transcending politics and geography. When we come together, regardless of our backgrounds or beliefs, we become stewards of this fragile world. Our collective efforts ensure that future generations can look up at the night sky with wonder, not fear. So next time you look up, remember, the sky is full of surprises, mysteries, and possibilities. We are all guardians of our home, united by curiosity and a shared sense of responsibility. The story of 3I/Atlas inspires us to stay curious, stay prepared, and keep exploring the unknown. It's a call to action for everyone on Earth. The universe is always changing. New discoveries await us with every passing night, and our understanding of the cosmos continues to evolve. By watching the skies, we're not just observing distant worlds, we're shaping the future of our own planet, ensuring that Earth remains a safe and vibrant home for all.